Hello Geometry, we are doing the last of the notes for the year. Hooray, we're almost there. So we're doing the day 8 notes and then we're also going to review. So let's start with this. We're doing hemispheres and spheres today. Super easy compared to the other shapes we've been doing. A sphere looks like a ball, all right? All the points in 3 dimension that are equidistant from the center point. So this is what a sphere looks like a ball. Radius is going to be the distance from the center to the sphere. So radius goes from the center out to the sphere. And then the great circle is a circle that contains the diameter. It's kind of like the equator of the Earth. It goes around the widest part of the sphere. A hemisphere is going to be exactly half of a sphere. And so we're going to be finding the surface area and volume of spheres and hemispheres. For the surface area of a sphere, you're just going to do 4 times pi times radius squared. Or I always like to do 4 times radius squared times pi because pi goes usually at the end. But whatever. And then the volume is 4/3 pi r cubed. So notice this time the radius is to the 3rd power. But otherwise it's just using your calculator and plugging stuff in. So it should be pretty easy. So like for number 1, the surface area of the sphere is 4 times radius squared times pi. The radius is 11. So 4 times 11 squared times pi. Plug it in your calculator except for the pi part. You're going to get 484 pi square meters. All right. Oh, the answer's down here. Whoops. All right. The volume is going to be 4/3 radius cubed times pi. So you're going to do 4/3 times radius cubed times pi. Just do 4/3 times 11 cubed on your calculator. It doesn't work out to be the nicest number, so you can always just do math frac and leave it as a fraction. So when you do 4/3 times 11 cubed on your calculator, hit math frac, you're going to get 5,324 over 3. And then the pi is still at the end, and this time because it's volume, it'll be cubic meters. So if you ever get a decimal, just do math frac. You can leave it as a fraction. I know it looks weird, but that's it. Number 2, notice this is a diameter. The radius will be half of that, so 12. And then after that, it's exactly like the last one. Surface area is 4 times radius squared times pi. 4 times 12 squared times pi. You get 576 pi square inches. Volume is 4/3 times radius cubed. So 4/3 times 12 cubed times pi. Type in your calculator. It works out nicely. This time you get 2,304 pi, and this will be cubic inches. So that's a sphere. Hemisphere, normally I'd walk you through how to generate it. We're not going to do that. We're just going to do the surface area of a hemisphere and the volume of a hemisphere. The surface area of a hemisphere is going to be 3 times radius squared times pi. The volume of a hemisphere will be 2/3 times radius cubed times pi. All right, so those are the formulas you would use for a hemisphere. So we'll do that with like number 3 and number 4, and then we will get to the review. Surface area is going to be 3 times radius squared, 15 squared, times pi. Type that in your calculator, you get 675 pi. Don't forget to leave your answer in terms of pi. Volume is 2/3 times radius cubed times pi, so 2/3 times radius cubed, 15 cubed times pi. Type that in your calculator. You're going to get 2,250 pi cubic meters. All right, so it's just a matter of plugging stuff in the calculator. Hopefully that makes sense. The surface area for this one, same thing. 3 times radius squared, 33 squared times pi. Plug that in, you get 3,267 pi cubic feet. The volume will be 2/3 times radius cubed, 33 cubed times pi. Just make sure you use the correct formula. If it's a hemisphere, use these formulas. If it's a full sphere, use the other ones. And you plug this in, you're going to get 23,958 pi cubic feet. All right, so that's hemispheres and spheres. I also wanted to review. This review sheet here is up on Canvas. So this will be a really good kind of summary of everything. At the beginning of this unit, you had area, all right, and then we had surface area and volume. So I kind of wanted to go through everything because you have a test coming up soon. Parallelogram, remember you do the area of the base times the height. All right, Pythagorean theorem could possibly come up if, like, you know, this side, you might have to do Pythagorean theorem, but not always. Triangle, all right, the base, remember, is the bottom part. The height is the perpendicular distance from the base to the height. So if you have a triangle like this guy, the height is going to be this piece here. For this triangle, all right, the base is the bottom, the height comes straight down, it's perpendicular to the base. Formula: 1/2 times base times height. Circle, circumference, or perimeter, we call it both. It's 2 times radius times pi, or diameter times pi. Area is radius squared times pi. In a rhombus, all right, all 4 sides are equal, so keep that in mind. They might give you the perimeter, and then you can divide it by 4 to find out each of these pieces. The diagonals are perpendicular, so they do create 4 right angles. The formulas that you're going to use are either area is 1/2 times diameter times 1/2 times diagonal 1 times diagonal 2, or base times height, depending on the information. Pythagorean theorem's a possibility. You might need Pythagorean theorem to help you find some pieces, so keep that in mind. A kite. All right, these 2 pieces are congruent. These 2 pieces are congruent. You're going to do 1/2 times diagonal 1 times diagonal 2. Keep in mind that these diagonals are perpendicular, so Pythagorean theorem is definitely a possibility. Trapezoid. All right, the height is the perpendicular distance between the 2 bases. The bases are the parallel sides, B1 and B2. And the formula: 1/2 times the height times base 1 plus base 2. Make sure you add those first before multiplying it. You may have to do Pythagorean theorem. Notice there's a right triangle, so there's always a possibility of Pythagorean theorem with that. A regular polygon. So if you have a hexagon, that's really about the only one you're going to need to know. Remember that in a regular hexagon, when you draw in the apothem and you draw in the radius, this angle here is going to be 30. Okay, because 360 divided by 6 is 60. The apothem cuts it in half, so this is going to be 30. This is an S, not a 5. This is an S. So if this piece here is S, this piece here will be S root 3. So if this piece down here is 10, this piece here will be 10 root 3. If it's 5, it'll be 5 root 3. If it's 6, it'll be 6 root 3, etc. All right, this piece gets cut into 2 equal pieces. So if you know the whole thing's 10, then this would be 5, and that would be 5 root 3. The area of this is 1/2 times the apothem, so this piece here, times the perimeter. And the perimeter, you just figure out what the sides are and add them all together. Prisms, the more recent stuff. Prisms have 2 bases. You find the most unique 2 sides. Those are your bases. All right. When you're doing the lateral area, you do the perimeter of the base. So you'd have to do, 4 plus 4 plus 3 plus 3. Times the height. The height is the distance between the 2 bases. So in this case, 5 would be the height. The surface area is going to be the lateral area plus 2 times the area of the base. The area of the base would be the area of this shaded guy, which would be 3 times 4 or 12. So be careful. Height and base get a little confused. This guy's a triangular prism. This triangle is your base. So when you find the area of this, you're going to do the area formula. 1/2 times 3 times 4. All right. The perimeter of the base would be these 3 sides added together. 3 plus 4 plus 5. All right. So you have to be careful. I put all that work right here. 3 plus 4 plus 5. The area of the base, 1/2 times 3 times 4. All right. For the rectangle, I did the work over here. All right. The perimeter would be 3 plus 3 plus 4 plus 4. And the area of the base would be 3 times 4. So you have to be careful and know what your base shape is. The cylinder is going to be, looks like this. You've got your radius, you've got your height. Perimeter is the same thing as circumference. It's 2 times radius times pi. The area of the base is radius squared times pi. The lateral area is the perimeter, which is the circumference, times the height. And the surface area is LA plus 2 times the area of the base. Volume's area of the base times the height. Cone, remember we have height and we have slant height. And then the radius. Pythagorean theorem is definitely a possibility to find one of those missing pieces. The lateral area is 1/2 times the perimeter. So again, the circumference of the circle times the slant height. Perimeter again, 2 times 4 times pi, that's circumference. Surface area is LA plus B. Remember, B is the area of the circle. Area of the circle is radius squared times pi. Volume would be 1/3 times the area of the base times the height. A pyramid. Okay, a pyramid will always have a square base, so I put S here for each of the sides of the square. All right, the height is this red line here. All right, L is this green line here. Notice it goes along the middle of the side. There is definitely a possibility for Pythagorean theorem with the height and the slant height. If you connect it with this blue line here, that blue line will be half of whatever this side is. So like if this side is 10, this piece will be 5. If this is 12, this is 6. And then you would do Pythagorean theorem with the blue, the red, and the green numbers. Perimeter of the base. So the perimeter of this square would be S plus S plus S plus S, or 4 times S. The area of the base, you just multiply S times S. There is a possibility of Pythagorean theorem with these as well. So maybe you're given the slant height and this bottom piece, and then in this piece as well. All right, you might need to use Pythagorean theorem using those 3 pieces. Lateral area is 1/2 times the perimeter of the base, so the perimeter of the square times the slant height. Surface area is the lateral area plus just the area of the base. And volume is 1/3 area of the base times the height. Make sure you use height for the one, slant height for the other. And then sphere we just went through, and hemisphere we just went through. All right, but I have it here. I don't have hemisphere written down, but we just did on the other note sheet, so you should be good to go. All right, so I would even have this sheet handy while you are taking your test. Definitely do the homework for this evening and for tomorrow evening. It's a really good study guide for the test. All right, good luck.